Okay, thank you, Prof, for the nice presentation. Thanks for organizing the symposium. Good afternoon, everyone. I'm Arnau Vidal, Mycotoxin Manager in Innovat. And today, I will introduce a little bit all the work that we have been doing in Innovat, applying for the first time extensively the mycotoxin biomarker analysis. First of all, I would like to remind you that normally in all these feed surveys, we detect that most of the samples are contaminated with mycotoxins, confirming that animals are continuously exposed to mycotoxins, and we need to protect them from this contamination. For the reason, the first step is to measure how big is the mycotoxin risk. And until now, to measure the risk of mycotoxins, we have been applying feed and raw material analysis. But we know that the feed and raw material analysis have a lot of limitations that do not allow to know which is the real mycotoxin exposure. For example, the heterogeneous distribution of mycotoxins do not allow to take a representative sample. Normally, mycotoxins are focused on the hot spots, so places where the fungi grows, produce a lot of mycotoxins, but then the rest is completely clean. Okay, so how to collect a representative sample when we have such a heterogeneous distribution? Also, maybe we collect today the sample, but the feed is not consumed after 2 weeks or 3 weeks, and mycotoxins can be produced very quick. For example, there are a lot of studies, but in this study they detected that in 2 weeks, we had more than 30 ppms of ochratoxin produced. So the content of mycotoxins can be completely different from the moment that we collect the sample until is consumed, the feed. And also, there are a lot of masked forms. What are the masked mycotoxins? Are mycotoxins that are produced by, for example, the fungi or the plant, so are metabolites produced by the fungi and the plant that are not detected in the routinary analysis, although when the animal intake the mycotoxin are converted to the free form, so they are as toxic as the free form, although we cannot detect in the routinary analysis. And moreover, it has been estimated that 50% of the total DON, for example, is in conjugated form, is in masked form, that is not detected in the routinary analysis. So for all these limitations, we cannot know which is the real mycotoxin exposure through the feed and raw material analysis. A few years ago, started to be possible the mycotoxin analysis in the biological fluids, so the mycotoxin biomarker analysis. And all the studies that compare mycotoxin biomarker analysis versus feed analysis, or even versus food, concluded that mycotoxin biomarker analysis provides a better estimation of which is the real mycotoxin exposure. Even there are already some studies demonstrating how to apply mycotoxin biomarkers and the success of this technology as a diagnostic tool. I put it here an example from swine, but it explains very well as an example of how this technology can be applied as a diagnostic tool because, for example, they detected that piglets that were suffering tail necrosis had higher significant levels of DON in the blood than animals that didn't have these symptoms. Okay? So as an example, that mycotoxin biomarker is a successful technology to demonstrate the real mycotoxin exposure. So for the reason, Innovat, in collaboration with Care University, the veterinary faculty, here we can see a picture of the huge campus that they have in Belgium, developed and validated a method to analyze mycotoxin biomarkers in blood. The method has been published. Initially, it was validated for 23 mycotoxins, but now it has been expanded and it's already including 36 different mycotoxin biomarkers. What is relevant from the method validated is that the sample is collected using FDA cards. So with just 1 drop of blood per animal in the card, the analysis can be performed. So directly from the wing to the card, and the analysis can be performed in a very easy way. It's possible to collect the samples to analyze the real mycotoxin exposure. It sounds very easy to take just one drop of blood from the animal, put in the cart, and discover the mycotoxin exposure, but there was a lot of research before to get to the method. First of all, for example, it was necessary to understand the metabolization of each mycotoxin and also the differences between the animal species. As an example, that it shows very well the differences between a species. For example, DON in swine is metabolized to DON glucuronide, while in poultry species is mainly metabolized to DON sulfate. So it's necessary to understand all this for each mycotoxin before to get the final method. So what we have been doing during these last years was collecting raw materials, feed analysis, analyzing them always with chromatography, with high sensitivity. And moreover, we have been including the blood analysis with the FDI cars and combining all the different pictures, try to understand which is the real mycotoxin exposure, which is the real impact of the mycotoxins. At this moment, we have analyzed almost 4,000 birds from around the world, from 32 different countries. Here you can see the distribution, mainly layers, breeders, but also broilers. From all these analyses, we can extract 5 main lessons, conclusions that I will try to introduce you now in the next slides. First of all, that the mycotoxin risk ignored in the feed, but detected in the blood. So here, first of all, we can see the number of mycotoxins detected in the feed analysis alone. Even some samples were clean, no mycotoxins detected. So the farms from these feed samples, from these collected feed samples, could think that there is no mycotoxin risk in their farms because the feed analysis is clean. And most of them had 1, 2, or 3 mycotoxins. But when we added the blood, we detected more mycotoxins, confirming that with the blood we detect better, which is the real mycotoxin exposure. First of all, we detected mycotoxins in all the farms, confirming that the mycotoxin risk is always present and animals are continuously exposed to mycotoxins in all the farms. Moreover, most of the cases, because 97% of the cases, animals were exposed to 2 or more mycotoxins. Even 50 or more than 50% of the cases, animals were exposed to 5, 6, 7, 8 or more than 8 different mycotoxins at the same time. As you know, the co-exposure to different mycotoxins have a synergistic or accumulative toxic effect, so a higher toxic impact, the exposure to different mycotoxins than individual exposure. Moreover, just to confirm the other value of the blood analysis, in more than 80% of the cases, mycotoxins analyzed in the feed and in the blood were only detected in the blood. And I will show a lot of examples in the next slides. And for example, one example in US, in a broiler producer that we collected samples at the end of each stage, feed and blood. And here we can see the results from the feed and from the blood. And for example, in the blood, we detected aflatoxins here that were not detected here, or zolanon that were not detected in the feed. And as you can see, this tendency was for all the analyses that we performed through the entire cycle, and confirming that in most of the cases, thanks to the blood analysis, we can detect a mycotoxin risk that is missed in the feed and understand better which is the real impact of the mycotoxins. Lesson learned number 2, large presence of emerging mycotoxins. It was surprising to see that the most frequent mycotoxin detected in the poultry farms was not DON, was not ochratoxin, was twenazonic acid, that most of the people ignore this mycotoxin, and moreover was followed by anything B1. All these mycotoxins are emerging mycotoxins that, if we check the different scientific feed surveys, it was already confirmed the large presence of these mycotoxins. For example, in this scientific feed survey, they analyzed 183 samples. Although DON is very frequent, it was not the most frequent. The most frequent was veovaricin, followed by eniatins. or alternariol and tonosonic acid much more frequent than fumonicins and aflatoxins that we're always including in the routinary analysis. More than 500 samples, xenon was the most frequent one, but followed by enietins and velvoricin, or tonosonic acid detected in almost 75% of the samples. Or in this other scientific feed survey, more than 1,000 feed samples analyzed, and enietins were the most frequent ones. So, thanks to all these analyses that we did, we confirmed the large presence of emerging mycotoxins, and if we only focus on the 4, 5, 6 legislated mycotoxins, we're missing a big part of the mycotoxin risk. So we need to also include these emerging mycotoxins in the routinary analysis, because otherwise we are missing a big part of the mycotoxin risk. The emerging mycotoxins, very quick, just a little bit of information about them. They also can be classified depending on the fungi that is producing. We have, from one side, the ones that are produced by Fusarium, like DON, that here we found enietins and velvoricin, and the ones that are produced by Alternaria. This is also important because until now we were always saying that Fusarium, Penicillium, Aspergillus are the main fungi producing mycotoxins, but now also Alternaria is getting a lot of interest because we have detected the large presence of Alternaria all over the world. The main mycotoxins that produce Alternaria, alternariol and tonosonic acid, that actually tonosonic acid has been the most frequent one detected in the poultry farms. And what about the toxicity of these emerging mycotoxins? Because we know that they are more frequent than the famous ones. We don't know yet completely in big detail the toxic impact of these mycotoxins, but we know that they are as toxic as the famous mycotoxins. For example, one scientific study evaluated the toxicity of these mycotoxins for intestinal cells. We know that DON is highly toxic for the intestinal tract. Enitin A1 is even more toxic than DON for the intestinal cells. Or velvoricin and enitin B, also highly frequent mycotoxins, are also considered highly toxic, and they can co-occur most of the times. And also, one recent study that demonstrates the importance of including emerging mycotoxins in the routinary analysis. It was in piglets, but I'm sure that in poultry species it's exactly the same. They detected that when the piglets were only exposed to DON, the growth was not affected. But if the same concentration of DON was added to enietins and velvoricin, then there was an impact in the performance. So if we only analyze DON, we will not be able to find the correlation between mycotoxins and the performance. But if we expand the number of mycotoxins that we analyze, we will be able to find the correlation between mycotoxin exposure and impact to the performance. Also, very quick about tonosonic acid, that it has been the most frequent one detected in the poultry farms. We don't know yet a lot about this mycotoxin or the toxic impact in the poultry species, but we know that, for example, it causes intestinal ulcers, hemorrhages, gizzard erosions, liver and kidney injuries. Also, based on my own observations around the world, I already detected some layer producers that they observed that when there is a high exposure to tonosonic acid, it seems that there are some alteration in the pigmentation of the egg. So probably in the coming years we will be able to demonstrate scientifically this impact of tonosonic acid in the pigmentation of the eggs. So just before to conclude this topic of emerging mycotoxins, the importance of controlling them to understand better the impact of the mycotoxins. And also in Europe, EFSA already started to establish some limits for some of these emerging mycotoxins, confirming the importance of controlling them. Lesson number 3. We detected trends between mycotoxin exposure and health symptoms. When we collect samples, we request a kind of questionnaire to try to understand the health status of the farm that we are evaluating and find the correlation between clinical symptoms and mycotoxins detected. And actually, we detected some associations already. For example, 22% of the analyzed farms were suffering necrotic enteritis. And we detected in these farms a higher exposure to DON and also to DON and fumonisin. And actually, it has been demonstrated scientifically, and in the speaker from the next speaker published this nice study that they detected this correlation of considered low levels of DON and fumonisin and increase of necrotic enteritis. So actually, what we detected in the farm has been already confirmed in different scientific studies, or 2 more studies that detected the correlation between DON and increase of necrotic enteritis, and exactly the same for fumonisin. Also, 14% of the cases said that the farm was having kidney problems. And in these farms, we detected a higher percentage or a higher exposure to ochratoxin, confirming the association between ochratoxin exposure and increase of kidney problems. And finally, also, we detected a high correlation or high co-exposure to different mycotoxins when there was a high susceptibility to other infections. We know that all the mycotoxins, all of them, have a big impact on the immune response. So this high co-exposure to different mycotoxins, although at low levels, can be associated to this high susceptibility to other infections. So all these analyses, and we expect to expand the number of associations that we are able to find, are confirming that all these biomonitoring programs can be used as a diagnostic tool. But not always is diagnostic tool, not always there are clinical problems, because the mycotoxins, when they are at low concentration, not causing clinical problems, are having also a big impact in the performance. And we have been able to find correlations between low levels of mycotoxins and a reduction of the performance. And there are more and more studies focusing on this correlation between low levels of mycotoxins, considered safe levels, and having an impact in the performance. For example, low levels of DON and fumonisin reduce the weight of the broilers, or they detected some correlations between low levels of mycotoxins and an increase of the feed conversion rate. Okay? And not only with then DON and fumonisin, also with emerging mycotoxins, as bevoricin and inietins, confirming again the need of controlling also the emerging mycotoxins. Okay? So how these low levels of mycotoxins, considered safe levels, actually have a big impact in the performance. So we decided to try to understand if with the biomonitoring programs we could find the correlation between low levels of mycotoxins and the impact in the performance. So we did an evaluation. We did 2 groups, control group and a group consuming or adding a detoxifier technology. And at the end of each stage, feed and blood were collected for each group. Okay? And the concentration of the detoxifier technology was also reduced through the cycle. Even we added a very low concentration at the latest stage, at 0.3 kilos per ton, when we normally suggest 0.5 as the minimum dosage. And first of all, we analyzed the feed. So here we can see the feed results at the end of each stage for the control and the group consuming a detoxifier. We analyzed for 16 different mycotoxins, the feed, but we only detected 3 or 4 mycotoxins. The results are in yellow because the levels detected do not suppose a high mycotoxin risk for broilers. Even if we compare the maximum concentrations detected with the maximum or with the limit established in Europe, we see that we are very far from the maximum limit. For example, 380 ppb is the maximum concentration detected in the feed samples when the maximum is 5,000 ppbs, or 2 ppbs of aflatoxin, the maximum allowed, the maximum detected, when 20 ppbs is the maximum allowed. So considering the feed results, we cannot consider that there was a mycotoxin risk in these farms. But then we added the blood. And as I said before, and as in more than 80% of the cases, mycotoxins detected in the blood were not detected in the feed, even aflatoxin, the most toxic one. But then, in the control group, we detected 8 different mycotoxins in the blood. But in the group consuming the detoxifier, only 2 mycotoxins, confirming that with the detoxifier, we are reducing the exposure to mycotoxins. We are protecting the animals. At 0.7, still less mycotoxins. At 0.3, there was no less mycotoxins in the blood, confirming probably that 0.5 is a very good minimum dosage. So thanks to the blood analysis, we could understand that which was the real mycotoxin exposure, which was the real mycotoxin risk that was completely missed in the feed analysis, and confirm that with the detoxifier we were reducing the mycotoxin exposure. And then the performance was evaluated. It was detected that animals with less mycotoxins in the blood consuming the detoxifier had better performance because the final weight was better, and also the feed conversion rate and the average daily weight. So thanks to the blood analysis, we could see that the exposure was lower, and then we could correlate these levels with the performance, and we could see that there was a significant increase in the performance. So all these biomonitoring programs can be established to understand the performance in the farms, although the levels of mycotoxins are considered low. Okay? This was in broilers, but it can also happen in layers. So in layers, very quick, one example of a case where we collected blood samples before a detoxifier introduction. And 2 weeks later, after using the detoxifier, we repeated the blood analysis. And here we can see the blood results. While before the detoxifier introduction, we detected DON and torazonic acid in the blood, 2 weeks later, DON was completely removed, torazonic acid was reduced 10 times. So thanks to the blood analysis, we could see the efficacy of the detoxifier, see how the levels of mycotoxins could be even removed, because DON were removed, and this had an impact in the performance, because the weight of the egg was increased 5% in the group using the detoxifier technology, while the control group still had the same initial weight. And all this technology, all these biomonitoring programs can also be applied to understand, to evaluate the mitigation strategy. Because until now, to measure the efficacy of the mycotoxin binders, we only had the in vitro binding studies, or the in vitro binding trials. And everyone working with mycotoxin binders know very well all these in vitro binding results that are performed in the laboratory, in a glass where you put the binder, you put the mycotoxin, and you evaluate the binding capacity. But what you have in the results in the laboratory cannot happen under real conditions, because in the animal is completely different, the conditions. So for the reason, even in Europe, the EFSA said that this type of in vitro binding trials cannot be used to demonstrate the real efficacy of the product that is necessary to test under real conditions, for example, in the animal. So for the reason, all these biomonitoring programs can also be established to evaluate the efficacy of the mitigation strategy. And here an example. 2 different detoxifiers were evaluated. 1 month after using the detoxifiers, feed and blood were collected for both technologies. And here we can see the results. Theoretically, the feed was exactly the same, but problems of the feed analysis. There were some differences because there were double DON here than here, more fulminisins here, T2 here, but not here. So as normally we detect very heterogeneous results in the feed, and we cannot trust on the feed analysis. But then in the blood, we detected that all the animals under this detoxifier technology had DON in the blood. All these animals had torazonic acid in the blood, while animals under this detoxifier, only 20% of them had DON in the blood. Torazonic acid was not detected in the blood. So what these results are showing that animals under this technology had less mycotoxins in blood, were more protected against mycotoxins, and moreover, it was detected a reduction of the mortality, 50%. So all this technology can be used also to evaluate under real conditions the efficacy of the mitigation strategies. So to conclude, repeat a little bit the 5 lessons that we learned after applying extensively all these biomonitoring programs. First of all, that the mycotoxin risk ignored in the feed, but is detected in the blood. So in more than 80% of the cases, we detected mycotoxins in blood that were not detected in the feed. The large presence of emerging mycotoxins, because they are the most frequent ones. If we don't add them in the routinary analysis, we are missing a big part of the mycotoxin risk. The trend between mycotoxin presence and health status, for example, the association between DON and fumonisins, or a higher exposure to DON and fumonisins and necrotic enteritis. The correlation also between low levels of mycotoxins and the reduction in the performance, and how these biomonitoring programs can help to understand the performance in the farms. And last lesson learned, how all these programs can be used to evaluate the efficacy of the mitigation strategy to improve the performance. So, thank you.